Hello and welcome to my first lecture. This one is supply and demand, the supply and demand curve. The purpose of this lecture is so that you can see it graphically and visualize various changes or shifts in supply and demand. Now this lecture is for both my microeconomics and macroeconomics courses. What I want to do, if you're in macroeconomics, is give you a visualization of supply and demand and how we can start to see various things come into play, price and quantity, things like that. If you're in my microeconomics course, please pay close attention to the latter half of this lecture when I go over the formula for percentage changes. Now, if you're in my macro class, it's okay to look at the percentage changes and the formula for that. We will use a very similar formula for percentage change of GDP, gross domestic product, in the very near future. In fact, it will be on exam 1. So let's go ahead and start the graph and look at it. We know that if we have two variables, just from simple algebra, we can graph them using the x-axis and a y-axis. So I'm going to start there. Let's start off with our x and y, and this marker is about to die. So grab another marker real quick. Now, our y-axis with the supply and demand curve will actually be our price. So I'm going to label that P for price. Our x-axis will be Q, or quantity. So we have the very start, the very bare bones of our supply and demand curve. Let's look at supply first. Supply is the producer side. That's the amount of a particular good that you're going to produce or sell. Now, if we were talking about a specific firm, for instance Taco Bell, and the amount of tacos that they wanted to produce for a particular person, then it would be very specific. Now, if we were talking about a full market, let's just say the market for tacos, we might talk about it for the whole state of Texas. So the market for tacos would actually give us a comparison for how many businesses can actually produce tacos and at what point are they overproducing and things like that. I love Taco Bell, by the way. Well, the way supply works is that it's a positive relationship, and in other words, as you keep producing, you continually produce more and more items. You cannot, it's just physically impossible or logically impossible to produce at a negative rate or a negative amount of goods. Not necessarily producing less and less, but just producing negatively. I can never go up to here and then go like that, because at that point I'm really just destroying some of the goods I've already produced. It's just impossible to go back and not produce what I've produced. Don't get hung up on that too much. Just know that supply is always a positive relationship as far as the supply curve. Now, when we're looking at supply, it's positive and it's the producer side, but there's another side of it. And this one is going to be the consumer side, or demand. I'm going to use orange for Broncos, blue and orange. By the way, the Broncos beat the Ravens the other night. Really awesome game. Demand is a negative relationship, and that has to do with the principle of marginal utility. And if you recall, margin is each additional unit brings you what, and if it's marginal utility, then each additional unit will bring you how much utility. Well, we know that because of the principle of marginal utility, each additional unit of whatever we have will bring us less utility. For example, my wife got me a Denver Broncos jersey, John Elway, for a wedding gift. Now, this jersey is really special to me. It's commemorative of the Super Bowl 1997. I'm a huge Denver Broncos fan. I love them, and I really like this jersey. I wear it for every single game. The other night, Thursday night, I was watching the game with my son. He's 3 weeks old. By the way, my son woke up really early this morning, so if I look really tired, that is why. He woke me up, my wife and I, up at 5:30 in the morning, and I decided it's my turn to sit with him. So I'm a little tired. But we watched the Bronco game the other night. I had my jersey on. And that jersey brings me a lot of satisfaction, utility. I'm happy with that jersey. If my wife were to buy me another jersey, that wouldn't bring me as much satisfaction or happiness. Now, if she were to buy me 100 more jerseys, that wouldn't bring me very much at all as far as utility or happiness. The reason being, I can't wear those jerseys enough to make use out of them, and the more I have of something, the less I continually want of something else. Or this same item, but just continually wanting it. So it's a negative relationship. In other words, it would look something like this. I'm going to label it D1 for this graph. I sure hope that you can see this on the video. I believe you will be able to. So if you will look at this, you can see that the point where these two intersect tells us something. It's a price equilibrium. It actually is really nice for our market. And we want to try to be at price equilibrium. That's the point when producers are able to maximize their profit and consumers are able to maximize their utility. Now, with this price equilibrium, you will be able to see that it intersects at a certain point on the price curve, or the price axis, or y-axis, and on the x-axis, it also intersects at a certain point. I'm going to label these P1 and Q1. Let's just say that we're talking about gasoline. Not the barrels of gasoline, the natural resource gasoline, but the actual gasoline you put in your car. And we're talking about your specific supply and demand curve for gasoline as a college student. Now let's say at this point, price point equals $3 a gallon. And at this point, the quantity, Q1, equals 10 gallons. So at this point, we can say the price equilibrium is 10 gallons of gas at $3 a gallon. You might be saying, Mr. Kemper, why did you do all this? It doesn't really matter to me. Well, it does, and I'll show you why. As supply shifts and demand shifts, we see a change in the price equilibrium. Let's just say that in West Texas, which we live in, there's a shortage of gasoline because there's a hurricane down in Houston. That will shift out our supply curve. It will shift it up. S2, it'll shift it out this way. In other words, shift it in and up to the left, decreasing supply. What you'll notice is if I were to show the equilibrium of this, it's actually decreased our quantity, the amount we want, but at the same time, increased the price per gallon. Let's say it's $5 a gallon at 8 gallons. That's the amount you want, $5 a gallon. Well, let's look at the percentage changes of these particular items. If you'll recall, percentage change formula is just 2 minus 1 over 1 of whatever variable you're talking about, the absolute value. If we're getting the percent, it's times 100. For instance, with percentage change of price, we would look at P2 minus P1 over P1. Now, this is in your book, so I'm not going to go over the formula that quickly or that much in detail. I'm going to go over it quickly because you can look in your book and try to figure out where I got these. What I'm trying to give you is a very brief summary so you can apply it to the book, go over the example continually. So we times that by 100 to get the percentage change. So P2 would be 5 minus 2 over 3, or actually 5 minus 2, 5 minus 3 over 3. P1, P1. Absolute value gives us 2/3 times 100. This is actually 0.66 times 100, 66%. You might be saying, well, why do we need to know that? Well, we know that as supply shifted out, there was a direct correlation with price. In other words, price increased by 66%. So what happens when price increases by 66%? We can actually go and look at the percentage change for quantity and figure out what happens. Same formula, except this time we're going to plug in quantity. Q2 minus Q1 divided by Q1, absolute value times 100. We've got 10 minus 8, or actually, I wrote that backwards, sorry. 8 minus 10, that's very important. Q2 is 8 minus 10, divided by 10, absolute value times 100. Well, this is negative 2 over 10, or negative 0.2. Absolute value, 0.2 times 100, gives us 20%. The reason why it's absolute value is we know it decreased, but all we want to know is the percentage it decreased. So we would say 66% increase of price led to a decrease of 20% in the amount we wanted of supply. Our demand decreased for that particular item. We essentially wanted more of it, but we can't afford more of it. Now, you might be saying, okay, that's great, but what about if not just supply shifts? And if you're saying that, you're really smart and you're thinking ahead. So what if demand and supply shift? Well, we're not going to go into the mathematics of this, but I do want to graphically show you what can happen. So, we have, in this simple graph, our supply and demand curve, our supply shifted this way. What would happen if our supply, forgetting which marker I'm holding, our supply goes up, S1 to S2, and at the same time, our demand, I know this is green, goes this way. So our supply shifted, I said goes up, it actually goes down, but it shifts up to the left, and our demand shifts up and to the right. Well, our equilibrium, instead of going from here up to here, it actually went up to here. And at this point, we're at P2, P1, Q1, Q2, here, closer to Q1, this is Q3. My markers are just not cooperating. That's okay. The reason why I didn't do all the numbers on there so you can see it pretty succinctly, P3 is higher than both P2 and P1. In other words, we're paying a higher price, but at the same time, we're still demanding more things. You might be saying, well, when would this happen? When would there be a shift in both supply and demand? Remember I just talked about gasoline, and if there's a hurricane down in Houston, that this would shift the supply. Well, let's just say something happened similar to Jersey just last year. And there was a hurricane there, but the power was out. So not only did the supply decrease, but you had an increase in demand because you need more power to run your generator to keep warm. Well, instead of just saying, well, I'll drive a little bit less, I'm going to pay more, I'm okay with that. You say, I'm going to pay more, but I actually have to have more gasoline. So even though I'm paying more, I'm still okay with it. My utilities changed as far as where I'm going to be at the curve. We'll talk about that more later on. But what you need to know is price equilibrium shifts as supply shifts and demand shifts. Hopefully you're not too confused with all of that. I'll go over it more in the lectures in the PowerPoint. But what I wanted you to see is how it formulates graphically and visually. Now, if you have any questions at all, please feel free to email me at jameskemper or jkemper@southplainscollege.edu. Once again, it's jkemper@southplainscollege.edu. And you can tweet at me at jameskemper. Hopefully this helped. Once again, any questions, feel free to contact me. Thank you and have a nice day.